Okay, it's 5 p.m. So I think we are all set. Let's start. So can everybody hear me? Okay, during the webinar, if you have any question or comment, please type in your question at Q&A or comment at chat in English, please. And then no recording, please. Okay, so hello everyone. We have something special down here at Zoom webinar this evening in Japan, morning in Germany. That is Saitama City Foundation for Business Creation, SFBC, and State of Bavaria, Japan office joint project webinar. Thank you for joining us today. Please let me introduce myself. I'm Kato from SFBC. I would like to take this opportunity to thank you all for your cooperation. And special thanks to Dr. Geltinger, Chief Representative, and Ms. Tayama, Project Manager, State of Bavaria, Japan office. First, we're going to have an opening remarks from Director of SFBC, Mr. Sasaki. Mr. Sasaki, please start.
Good morning and good evening, ladies and gentlemen in Germany and Japan. My name is Tetsuya Sasaki of Saitama City Foundation for Business Creation. Welcome to the joint webinar with State of Bavaria, Japan office. Unfortunately, COVID-19 is still widespread not only in Japan and Germany, but also all over the world. But I think we can overcome this difficulty by cooperating together to move forward. Today, Dr. Geltinger-san will make a presentation which is titled Toward 2030. Now we can find how we can be competitive globally toward the future. We will have 4 days for sessions, including today. So please utilize this opportunity to update your knowledge. By the way, I would like to make a short introduction about the relationship between Bavaria and Saitama. It has been about 10 years since Saitama and Bavaria began to start to cooperate in the industrial tie-up. Today's presenter, Dr. Geltinger-san, has helped us since then. And JETRO has also helped us since 2010. Every year, Saitama companies visit Bavaria and Bavaria companies visit Saitama. Last year, Nuremberg City and Saitama City concluded MOU to cooperate in mechatronics, medical device, Industry 4.0, and new energy. I hope this webinar will make our collaboration stronger and more positive. Thank you very much.
Okay, thank you, Mr. Sasaki. Let's start the webinar now. Toward 2030, the vision for Germany Industry 4.0 and its collaborative approach with Japan by Dr. Geltinger, Chief Representative of State of Bavaria, Japan office. Dr. Geltinger, please start the presentation.
Thank you very much, Kato-san, Sasaki-san, for this introduction and this opportunity actually to do this joint webinar together as a symbol that we actually put our forces together jointly in synergies to actually reach a common goal that our companies and our industries become more competitive together. I think that's the general scheme, not only for today's seminar, but also for the following 3 other seminars that you also kindly invited to already. So let me start by giving you an approach, I would say, towards 2030. That is quite a far way. That's still 10 years to go. My take on the vision of Germany's Industry 4.0, and not only that, but also the collaborative approach with Japan, which I think is a very important notion that Industry 4.0 is not a German-only activity or initiative, but it goes hand in hand with other countries and especially with Japan. For the starting slide, I selected this quite famous castle in the south of Munich, Neuschwanstein Castle. which is not just very popular among Japanese, it is also what we would call today a smart castle at the time. It was packed with innovation, it was packed with sensors and switches and buttons that the king could remotely control. So maybe he was already ahead of the time, and they gave a view on how things can develop if you put innovation into action. Starting off a little bit about our office, for those of you who have not been in contact with us so far, either from Japan or from Germany, we call ourselves, in English, that's the State of Bavaria Japan office, or the Freistaat Bayern Japan Repräsentanz, or in Japanese, the Bayerische Unity Daihyobu, established in 1988, so more than 30 years ago. And in fact, it was our very first overseas office of our state in the world. So we decided to set up an office in Tokyo. We are still in Tokyo. And it was also the first German state to establish its own representative office in Japan. So now we are more, of course, but at the time, I think we were the pioneer. The office itself is located here quite central next to the Tokyo Tower. If you want to visit us, you can still visit us, even in the pandemic. We still would be happy to receive you also in person. You would take the Hibiya line to Kamiyacho, next to Kasumi Kaseki, so next to the political center, I think, of Tokyo, and then you are 5 minutes walk to our office. Our head office, so to speak, is in Munich. That's the Bavarian Ministry for Economic Affairs, Regional Development and Energy, as it is called now. So kind of the Japanese METI. And our office, as I said, started in '88, but since then we established 27 other offices or representations in 24 countries. So we have quite a global footprint already. And hopefully we will also expand these footprints to other emerging markets. So the main mission is basically build a bridge between Japan and Bavaria, mainly when it comes to business relations, trade, investment. But we also like to exchange societies, that means scientists, politicians, cultural people from culture, people from sports, people from universities, professors and students alike. So it's really more than just an economic development office. It's more like an interface and navigation system for Japanese companies interested in Europe and Bavarian companies interested in the Japanese market. To quickly remind us all what Industry 4.0 actually is about, and I think words tell some, but pictures usually tell you more. So I would like to quickly interrupt my presentation here and show you a short video put together by the German Association of the Electronic Industry, ZVEI, in Germany. That is, I think, quite well done, and it illustrates the benefits of Industry 4.0 when it's implemented at the workshop level. And yeah, let's see what they put together. Just a second.
We have always had to concern ourselves with everything to do with increasing productivity. We need to get to the market quickly. We can't have any waste. We have to remain competitive on location. And I think that this is not just a subject relevant for management, it's important for everyone here. If we want to be successful on the market, we need to use this tool.
We're talking about Industrie 4.0. It is no longer just a theory. The practice is now being applied in many German businesses. The demands of a global competition have rapidly increased in recent years. However, in the innovative German market in particular, numerous companies have succeeded by using these challenges as opportunities. And just as the number of companies and products rise, so do the numbers of potential solutions that Industrie 4.0 can offer. Energy transparency systems now make it possible to monitor and manage all energy flows and use energy sensibly. For instance, the excess heat energy from a machine can be used to warm up other machines or to heat up the air of the production site in the winter. In order for it to work, one thing in particular must be in place.
We need transparency. What's happening where with the energy we're using? And in which areas can we possibly be more efficient? Or where can we substitute components to be able to save energy? But above all, we could sensitize our employees much more to the subject of energy. And that is really worthwhile.
Analyzing complex data not only saves energy, but also ensures the highest quality standards and seamless processes. Production is often about nano-precision. In the worst case, even a simple speck of dust in the wrong place could lead to an entire system malfunction. Smart networking with predictive maintenance can drastically reduce such downtime. Good samples, with which the produced workpieces can be compared to by the smart system, are the key. If the products deviate from the template, the system triggers an alarm. Even the smallest interferences can then be quickly identified and localized without it resulting in downtime.
I can continuously monitor the system and process as well as identify gradual changes to intervene at the right time and according to plan. By using good sample technology, we were able to improve output by 2 to 3%, and overall, calculated throughout production, that is huge progress.
Another example of how Industrie 4.0 can massively increase productivity is by moving away from rigid production lines and developing towards autonomous, self-organized and highly flexible production islands. They can cover a very broad spectrum of increasingly complex and individual products and significantly reduce delivery times at the same time. The smart interplay between various mobile assistants for logistics, assembly and handling particularly enables this. They support and relieve employees and at the same time ensure optimum material flow. The smart factory is not just an example highlighting innovations. The figures it leads to are also impressive.
Compared to the old system, and depending on the product type we produce with these islands and systems, we've been able to increase productivity by between 20 and sometimes almost 50%. And at the same time, we've achieved lead time reductions of over 60%.
Less rejects, lower energy consumption, less down and setup time. Instead, more quality, more flexibility, more output, and improved working conditions. With its versatile innovative solutions, the German electro industry is on the best path to Industrie 4.0.
Yeah, thank you. Thank you very much to the association for putting together this quite impressive video. I think that the main message again is quicker reaction time. That was mentioned quite often. And the next slide actually shows what is meant by that. This is a more general schematic view on a process that starts with an event up here based over time, and the endpoint is actually then a reaction taken by the company. So the event, imagine, can be anything on the workshop floor, a machine failure, some downtime, a deviation from settings, maybe an earthquake, but maybe on a general scale, maybe something like a COVID-19 pandemic situation, or trade wars, or anything in general that actually happens and affects company. So the first step would usually be kind of the insight phase, where you actually analyze what's happening. And I actually try to actually register that something happened, I have to say. So the insight is that something is amiss, is going wrong. So this takes time. And then once the insight about the event is available to the people in charge, they have to, of course, analyze what has actually happened. And this takes also time, can be considerable, to fully understand the new picture, what happened, for example, at the workshop. And so once this analysis is then completed, some report has to be made. The operators have to communicate to maybe an upper level or to the colleagues or to the management. So the decision phase can take quite considerable time to finally make a decision how this new event or how the results or the effect of the event can be tackled, and countermeasures are initiated. So the measures, first of all, have to be approved by someone in the company, and then it goes back to implementing this measure, this decision, to finally come up with an effective measure that is then implemented. So this is more the general scheme. And if you then put Industry 4.0 into the game, the main idea is actually to shorten the time in all stages, basically. If you think about the first stage, the insight, this is more the question of what has happened, actually. And Industry 4.0 applications actually allow you to analyze or to identify an event in real time. So the immediate notification, information is available without delay. Especially if you have systems that are integrated, this phase A can be considerably shortened. Then, if you remember, it goes into the analytics stage, where we actually have to analyze what actually happened. Again, Industry 4.0 can help you by implementing for example, big data analytics that are based on proven hypotheses. So you actually quickly understand, okay, if that event has happened, it might be of that nature. Let's speak it more in general terms. Again, you can also think of a digital twin in such a situation, a digital twin of your workshop or your industry or your factory, where you can actually already, let's say, analyze such a behavior beforehand. You can mimic a situation, so that is possible as well. And of course, you can put new powerful tools like machine learning or artificial intelligence into this context, where then the analytics becomes even quicker and hopefully also more reliable. The third phase, the decision-making time. Again, you can implement support systems to help you not only help you to quicker come to the decision, but actually to visualize the actions that have to be taken on the shop floor. So this is, I think, a very powerful tool. You can think of AR or VR systems or mixed reality systems that actually allow you to visualize the action that needed to be taken. And of course, you can also automate this to a certain degree. And in the last stage, when you remember, this is now putting the decision into action. Again, you can shorten this considerably by integrating your systems vertically or horizontally to have automated processes in your workshop. And this is the core of the Industry 4.0's concept, to have cyber-physical systems in place. That means physical systems, machines, sensors that are connected to the internet. If you look at the same concept from another angle to see actually this is more like a development stage, I think quite a lot of companies have been, let's say, digitalized to some stage. That means they are in phase 1 and 2. They have, of course, computer-controlled systems or manufacturing in place with some connectivity, with some internet connectivity, of course. That's, I think, the basis for any Industry 4.0 application or systems that you have to, that you want to put into your company. So very crucially, again, this is kind of a similar scenario. First question that you have to ask is, do I actually know what's happening? So do I see what happens on my workshop floor or in my company? So the phase here, the number 3, the visibility is very important because it starts exactly there. And Industry 4.0 solutions can also give you this tool from a remote place. So you don't actually have to be inside your own factory. You can actually analyze and make processes visible from remote, especially now in this pandemic situation. I think it was a very helpful tool for many decision makers to be able to visualize the processes in real time in your company from any place on earth, basically. Then the second question is basically to understand what's going on. So why is it happening? This puts you in the analytic situation where you can analyze from experience, from personal experience, from skilled labor, but also you can, of course, put in artificial intelligence at this stage. And the next question is actually a result of understanding why is it, what will actually happen if this scenario comes realistic. So this predictive capacity, I think that was also in the video, is a very powerful tool that you have in hand to not only predict the normal flow of your process, but also to predict possible maintenance points that are helping your company to avoid breakdowns of equipment, of machinery, to avoid downtimes, which are usually very costly. So this predictive capacity is a very important block. And then the last stage, number 6, is more if you put all things together, you would like to have systems that actually, let's say, make it life easier for you than make an autonomous response. So an intelligent response that you actually can run in the background, that you actually can monitor, but you don't have to take action manually or physically. So a system that is adapted or has the opportunity to show some adaptability, to self-optimize. That is also a term that when it comes to artificial intelligence, a learning process that if one event has happened, you can learn from it and go to the next event prepared even better. So German industry is surveyed every year by the so-called BITCOM, that's the German Association for IT, Telecom and New Media in Germany. And this survey result has been just released in, I think, May this year, so it's quite new data, where they analyzed and surveyed and got feedback from about 550 companies from German industry. And the results, I think, are quite positive or can make one optimistic looking into the future. When asked, are you using specific applications for Industry 4.0? The overwhelming majority answered with already in use, already in place. So this rate has been growing from the last in the last 3 years from 49% to 59%. So a steady increase of companies actually implementing Industry 4.0 in the German industry. Companies that are basically ready to go, this margin has been quite steady, about 20 to 22%. If you put these numbers together, then you end up with these 81% of companies that are already using or plan to use Industry 4.0. So that's quite the majority of company. And again, you see that compared to 2018 or 19, where this rate was about the 70% rate, we see a steady increase. We see also, of course, companies that have currently no plans to implement specific Industry 4.0 applications, but they are considering to do so in the future. So they need to maybe be convinced a little further, or even need maybe more pressure actually to put industry applications in their business case. And the minority, only 1% answered with no plans at all. I think that number is probably very important, that you have a high awareness of Industry 4.0 as a concept in the German industry. Now to the main topic of today's webinar, the 2030 vision for Industry 4.0 was actually published this year. It has been presented already in the media online, and will be presented at the Digital Summit, the German Digital Summit, which is about to happen in the next few days. It has been put together by the Federal Ministry for Economic Affairs, so the German METI, together with the Industry 4.0 platform. And I'll come to that in a second, but you see it's not only the vision for the Industry 4.0, but it's meant to be the digital ecosystems being shaped globally. Again, I want to stress the point that this Industry 4.0 is, of course, a German term. It is even pronounced German, even in the English-speaking world, but the main aim is actually to connect economies on a global scale. This has also to do with the German economy, or the German industry has quite a global footprint. So it wouldn't make sense to just implement a system in Germany, whereas then the subsidiaries of German companies overseas would struggle actually to benefit from it. So the international approach is in the DNA of Industry 4.0. So the Industry 4.0 concept was coined a little bit in the mid-2000s. It has been, let's say, promoted quite prominently at the CeBIT trade fairs in Hanover, especially the one 2017. Maybe some of you have attended it as part of the huge Japanese business delegation that attended together with, at the time, Prime Minister Abe, who together with our Chancellor Merkel actually stressed this Japanese-German international cooperation effort that you can see here also in the pink box. This is part of the Industry 4.0 platform, but the main work is actually done here in the 6 working groups on the reference architecture, standardization and standards, technology scenarios, the security of it all, the legal framework around Industry 4.0, work education and training, so bringing this concept actually to humans in the workflow, and then develop business models, new business models for Industry 4.0. On top of the platform, you see 2 ministries working together. That's the Ministry for Economic Affairs and the Ministry for Science and Research, the BMBF and the BMWI. So this is also important to know that it is not only one ministry in charge, so actually it's 2. And of course, the commerce and trade unions, science researchers are part of this concept. So if you're familiar with the German cluster concept, this looks quite similar. You have members from industry, you have members from science, from research, you have members from governments, from associations like here Bitkom, like the CVEI, like the VDMA, who has also worked with Saitama already, or the BDI, the German Industry Association. And also, a very important pillar is the yellow or light greenish one, the implementation part. It is not just a theoretical discussion that is going on, but the implementation of the ideas, the tests of concepts, the proof of concepts. This is very important that Germany has set up this Industry 4.0 transfer network with regional competence centers or regional labs that allow you as a small company or as a medium-sized company to actually test applications in this setting. So you don't have to invest beforehand. You can just try, make an outsourcing effort to partners like Fraunhofer Society or these industry network labs that are spread across Germany. So the vision actually has 3 pillars. It is around autonomy. That's, I think, probably the major part of it. The technology development comes with the security and, of course, the infrastructure that is needed to achieve this autonomy and to develop digital business models. Equally important, the interoperability. I will talk about this in the next slides. The system have to be cooperative, have to be open to some point to permit the flexibility. And here we're talking about standards that have to be developed and integrated. Things like decentralizing systems to make them more flexible and accessible and more intelligent by using artificial intelligence systems. And the third pillar in the vision, and this has to do, of course, with the immediate action that have to be taken about climate change and circular economy efforts, the bioeconomy efforts. This is crucial for the survival, not only of us as a human or race or Earth in general, but actually also our economies have to think more in circular terms, from purchasing, from sourcing down to recycling or upcycling the products. And of course, social participation, so the human as at the forefront of all these technological innovations is part of the sustainability efforts. Now, if we talk about 2030, that's 10 years ahead, and I found this, I think, quite nice, but also quite mind-blowing. A picture or a statement from presumably a father saying, "I'm now in the getting old department." When I saw this, a kid saying, "Oh, you 3D printed the save icon." So the kid knew the save icon, but had no idea what this that this is actually a floppy disk from old ages, which are not that old. Probably all of us remember using that 3.5-inch floppy disk quite often, and to our dismay, that's history. That's not so long time ago. So we can really be curious where we end up in 10 years in 2030 when this, the vision is actually implemented or becomes reality. So let me start with the autonomous part of it. I highlighted here the security, because this is a very recent effort that we also did together with Japan. The so-called Third German-Japanese Security Forum that we organized together with the Cybersecurity or Security Network Munich. You see here the CEO, Peter Möhring, who also happened to give one of the next lectures here in our Saitama series. We were happy to have him aboard and continue the dialogue into what's happening in industrial security systems and information systems and information security. He will give a very detailed insight on the actual challenges at the moment, the threats that the industry is facing and also give an outlook, what can we expect from the future. How do we actually come to a situation where security is implemented by design in sensors, in all the cyber physical systems, in the processes, so we actually stay on the safe side. I think yesterday or so I read the news that there was a survey among global businesses, among their being attacked recently, and I think 200 Japanese companies answered in that survey, and half of, I think 50 or half of them have been attacked quite recently by ransom attacks, and actually also quite a number of companies actually had to pay to be released from the ransom. And this is quite a serious issue, so we are happy actually to have this dialogue platform established between German experts and Japanese experts. Just to give you a better understanding who actually is part of our forum, I think we had speakers from the METI, from the Directorate for Cybersecurity, for the Japanese Network Security Association, from Industrie, from Mitsubishi, for example, or from NTT, and also from the IPA. In the next couple of minutes, I would go into a little bit more detail about the interoperability, because this is probably what gives the most headache to companies when we talk about also standards and integration, and ways actually to come together. The Industry 4.0 platform has realized that this must be an international effort. And again, Japan has been selected as one of the global partners to co-develop and harmonize standards. The partner in Japan is the Robot Revolution initiative and the Industrial IoT initiative. Again, this for all of you who are more interested in what is actually discussed on harmonizing standards for industrial IoT. This is a publication released also this year by the two councils. So in both languages, I can really encourage you to dive into this publications. Just for your reference, I highlighted or picked a few reports that have been published both in Japanese, in German. One here, for example, on dynamic engineering of plants, so manufacturing plants, of course, and the other, the usage view of asset administration shells, or AAS in short. A very important approach that I will highlight also later on. So please make use of these publications that help you to understand what Germany and Japan are discussing in a cooperative and also friendly manner that we want to reach the goals together. Again, another publication that has been released recently was on value-based services. So actually application scenarios, real-time scenarios that makes it probably more attractive for Japanese companies, especially to increase their share of companies to implement Industry 4.0 or connected industry approaches. So in the next few minutes, I will touch on a scenario that touches as well as on autonomy, as well as the interoperability, because of several working groups have been active on what is called the so-called collaborative data-driven business model development by collaborative condition monitoring. What is meant by that? Condition monitoring means the condition, let's say, at the workshop floor of machines, of processes. It can be, for example, temperatures that are a condition of machines and temperatures, pressures, and so on. And the idea was to develop a scheme on how cross-company collaboration can actually generate added value. So looking more on the positive side of it, how can suppliers, manufacturers, come together to generate more value. This was a webinar that has been conducted recently in September. It was a very interesting effort by the platform Industry 4.0 to present this scheme. The scenario here on the right side is like a basic use case. You have a manufacturer X depicted here in pink that has sold its machines to a company, to a manufacturer on the right side, along with other machines. Of course, this manufacturer has some responsibility and reliability, legal liabilities as well on its machine, but it's always the question how this manufacturer, this supplier can access its machines once they are installed at the customer. So this is a very real scenario, especially when you think not only of one manufacturer, but several manufacturer machine suppliers with different products, with different components. If you look at your own workshop, you will probably have this scenario that you're not only buying from one supplier from several, you have several platforms, you have several components that are packed together in your production line. But the idea was to actually come to a cross-company, cross-competition. That's very important, cross-competition. So even competitors are here in the same boat in sharing crucial data. Sharing crucial data, but also sharing data that are not so crucial, but can help all the parties involved to generate more benefit for all of them. So the important thing is here that this data have in some way to be classified that allows them to be shared among the partners. The question in this scenario in the workshop were actually discussed quite intensively. They started with this last year, but this is the presentation from this year. Key questions. Again, the first question always you have to look at the business side of it. How can data be monetized? So how can you extract value from data and how you can actually share benefits by collective data provision? How does artificial intelligence even expand the options? Or how does flexible communication is made possible between all the partners? This is very important to set up a system where communication is possible among all partners. Communication comes then, of course, with security and trust and guaranteed access to data. This was an important question. And of course, you have to be on the safe side, you have to be on a legal sound side in actually using the data. So there needs to be a framework where all parties feel comfortable in legally using the data and not infringe on each other's proprietors. And last question, how can we actually make this all available and understandable to the workers on the shop floor? So how can we bring it down to the people that actually work with the machines, the operators? So they came up with two scenarios. On the left-hand side, this is more the classical standard setup, the linear, you can call it also linear approach. In this business ecosystem, you have on the left suppliers of components, X, Y, Z. There's no names, no brands, but they would actually supply a system provider, a machine tool manufacturer that incorporates all these parts, puts together the machine or the system and sells it on to a manufacturer, an OEM, who installs it in its production system. So you have the clear flow of components, the machine into the manufacturing, quite linear approach. Again, the scenario on the right-hand side is not involving other players. It's basically also the component suppliers. It involves the machine supplier and the production system. but the setup is different. Now we are not talking about a linear buy and sell approach, but actually these three set up more like a triangle, and data or communication flows between all three of them. So suppliers communicate with the machine supplier and back and forth, but they also in some way communicate with the production, the OEM. So it's more a collaborative approach. And if you think of this triangle as a space, this represents in this thinking the value that is added in making use of data shared among the three parties. And to increase the value, to increase the space of the triangle, you can think of bending these arrows so you actually create more space under these arrows. So they have looked at a typical standard, let's say, manufacturing workshop factory. We have an incoming order that is processed, that is not on the workshop yet, that it flows in. A product that has to be, let's say, guided and guarded and transported through several lines, be it here, for example, laser cutting or punching or bending machines, and in the end it goes into welding process. It ends up in packaging of a finished product, and then the product goes out of the factory and is ready for shipment to another customer, and so on. So this is like a very standardized process, standardized workshop. So they looked at each of these stages and picked here, for example, the first step with the key question actually, who owns the data that are generated at these stations and who is able to work with the data? Because if you dive in, if you screen into this system, you'll find here the nice white and blue machine from a German manufacturer, I think, if you can recognize the brand. But of course, in this system, there's quite an abundance of parts, of drives, PLCs, NCs, controllers, IOs, cabinets, control centers, a firewall. So quite a number of, let's say, parts, speaking in general terms, that are connected. But again, it is quite important for the owner or for the manufacturer of this system actually to have good access to all the components while the OEM is running the machine. And this is not so easy because of these barriers. I think in the discussion, they came across quite a number of problems that hinder the implementation of this collaborative approach. This is no-brainer that you have to create a certain level of trust among the parties, especially if we talk about systems that are interconnected with competitors. So the OEM has probably machines installed from competitive suppliers. How do you make sure that you don't get access to data that you don't want to be in the hands of your competitor, or you reveal your trade secrets or your production secrets? Then this calls for a framework, or the lack of a framework actually makes it more difficult to implement it. And you have to find partners that are willing to cooperate, to work on a cooperative effort. You can also call this, many industry calls this in the IT sector, the so-called open innovation approach, where you open up to a certain extent, but you can also be more innovative in this way. And then if you don't have many companies that are actually willing to do so, then you lack scalability. You lack certain level of experiences, and this is where artificial intelligence comes into play, because intelligent AI systems need a lot of data and scenarios where they can learn from So you only have a handful, a limited number of companies who are working on this collaborative model, then it's very difficult for an AI system actually to provide intelligent solutions or assistance to these partners. And then finally, you always want to have business models that are convincing enough that this collaborative approach is actually giving, let's say, benefit, profit, money to all of people that invest in such a scheme. So you need more business models. So this was quite an open discussion. And one solution to all the barriers that have been quite clear on everybody's mind is described here in quite a complicated, I think, manner, but nevertheless, you can again bring it down to the three players. Again, you have component manufacturers, you have the machine manufacturers, and the production systems, the workshop or the factory that is using it. They all have data streams in this scenario, which go into a cloud. They have been connected to this AAS, the Asset Administration Shell. I come to that in a minute. So you have different colors of data flow. Some are proprietary to the component maker or to the machine maker or to the OEM. And other data flows in gray, for example, they are not so crucial, they are not so proprietary, they can be shared. So they end up in these clouds. But the important thing, there's another layer that comes in that is now coined the Gaia X layer. And this gives, let's say, the sovereignty to the players, and also relieves them of headaches that actually they're giving away their trade secrets or their production secrets by putting things in just clouds, which have to be also trusted by everyone, especially if you come to a scenario where you have an outside component supplier X here on the bottom that also wants to access this layer and shares data with the layer. So fortunately, the Gaia X approach has been documented and published also in Japanese media, so you will find this term quite easily. It is actually not a German-only approach. It has actually stemmed from the idea as a European approach. The two leading economies in Europe, Germany and France, actually are working together as the main drivers, together with the other countries, to come to a European platform to bring more sovereignty to Europe. This is actually clear, let's say, a necessity to not be dependent on US-based systems or Chinese-based systems or layers or cloud systems that are available at the moment. So you can think of it as a European approach, which has some openness to interested partners on a fair level that want to also support the Gaia X platform. So what is it about? If you think about the collaboration of today, this is quite a complex scenario here depicted, maybe 4 companies. They're all interactive, they're all sharing either data or services. They have to understand their identities, they have to make sure their identities when they work together. So these red arrows. They share infrastructure at some point. So they have contracts among each other. So this is how collaboration is created today, multi-party, but it requires a high level of individual adaptations and agreements, which are not necessarily transferable to the next, let's say, customer or the next scenario. So the Gaia X idea is working more in an ecosystem, and is depicted on the right side, You can also think of it as outsourcing most of these, let's say, sovereignties, identity trust, compliance issue to another layer by certified providers. I will come to that in a minute. So you have either infrastructure as a service provider, IaaS, or you have platforms as a service providers, outside parties that provide these platforms that all these companies 1, 2, 3, and 4, and so on can access in a secure and reliable way. So this is the Gaia-X roadmap. It is a concept that has been established already early this year. Again, with providers, entities, and consumers. Do you have a different nomenclature here versus just supplier and manufacturer? We are talking more here in general terms, more data-based terminology in terms of providers and consumers of data across domains. You see that the timeline is quite ambitious. The concept phase that we are right now in the moment, fourth quarter of 2020, will go into a prototype stage early next year, and if 2021 will then see also hopefully the implementation and adaptation of this prototype. So target groups of this new ecosystems are, of course, businesses. As it's outlined here, Gaia-X targets business-to-business models, B2B models. But again, the individual citizen in Europe is the prime target of this ecosystem. The business consumers, they're mainly from healthcare, public sector, finance, or infrastructure, critical infrastructures. Whereas healthcare, of course, are critical infrastructures, but you can also think about airports or energy providers, where sovereign data infrastructure is key, is essential, and you don't want any interference or illegal interference from the outside or from other countries. And of course, consumers can also be associations, larger organizations, which combine in their membership various consumers. The providers as such, as I outlined, can be so-called software infrastructure providers to provide infrastructure as a service or platform, low-level platform as a service. It can also be platform and service providers that build solutions on top of the core infrastructure, of providers of real physical infrastructures. You can imagine data centers, hardware, networking, interconnection. So any provider of physical infrastructure is also a key component of this Gaia-X system. It's not just about software and cloud system, it's also about physical infrastructure. Again, the associations are part of it. And we have the facilitator side, that is more governments, politicians, that are crucially important to develop the Gaia-X ecosystem in a fair and reliable manner and secure manner. Again, we're talking about standards here. And this is work in progress. This has to be adapted to the needs. It has to be up to date. So the research world, the academia is an integral part of it, and it requires a lot of research actually to build the layer. I found this quite overwhelming collection of companies or brands and logos actually from already partners of the Gaia-X system. You can probably recognize a few of them from Germany, a few also, of course, from France. But so for them, what I learned from the research that Germany is really driving it. in France is putting a lot of money into the development. Again, this is the status at the moment. It will certainly increase. You can again see the concept like it has been realized in the Industry 4.0 platform. Establish working groups, so WG1 software architecture, WG2 operational infrastructure, 3 the storage, the computation and the networks, and the last one the certification and accreditation. So the concept in creating working groups or sub-working groups on the right side, I think has been proven to be successful to give this quite ambitious undertaking workable modules that are called working groups. And this is, I think, the right way to proceed. Why I'm showing all these logos, you will not find, but you will know that when I tell you that also Japanese companies are actually integrating into the Gaia-X platform. For example, Entity Network and Entity Data are already part of it and become a partner of Gaia-X. So another pillar that I want to describe, where we also have a clear interlink to Japan, touches on autonomy and interoperability when it comes to the trustworthiness of doing business together. Again, this has been published in Japanese and in English together with the Robot Revolution initiative and the Industry 4.0 platform. The role of trustworthiness, which I would briefly touch in these 2 scenarios. First scenario is actually a tender, a bidding process, where you on the bottom have a supplier that wants to supply parts or services to a manufacturer, to a buyer. This is a classical standard scenario. But to promote trustworthiness, in between those 2 parties comes a procurement platform, an evaluation platform, which is used by both parties, from down and from bottom. So what's happening is actually that the manufacturer, the OEM, starts the process by compiling trustworthiness expectations that the companies has for its suppliers. It creates a profile, the specifications that it puts into the platform. Then from the other side, the supplier starts the process by compiling its capabilities. What is the supplier able to do? Puts this into profiles, of course, corresponds to a request in terms of a bid and puts his or her data into the platform. The platform evaluates, matches expectations and capabilities in the end, gives like as a certification authority a certain recommendation to the buyer, which supplier to choose. The other scenario is a more direct scenario where you have the supplier and the manufacturer being closer in a sense that, again, the buyer, the manufacturer starts the process, again, compiles the worksheet of expectations and requirements, the specifications, but he hands this spec sheet to the supplier directly. So the supplier has direct access to the specifications. Based on the specifications, the supplier compiles its capabilities, puts this into a profile, a quotation, but then puts it in a platform, not directly to the buyer, but into the platform. Again, the platform, the neutral platform, matches the expectations, capabilities, evaluates the quotation from the supplier, verifies it, and then in the end, of course, again, gives a recommendation to the buyer which supplier to choose. If this is done, of course, then the system can also learn in the future based on the profiles that have been put forward by the suppliers. So this should eventually enhance the trust between, for this case, the scenario between German and Japanese companies, be it German, Japanese, small, medium-sized companies supply to a larger OEM in Germany with its supply management system, or a smaller German company, an SME, trying to sell to a larger Japanese company. They all have to gain trust. And so this is a current discussion between Germany and Japan in this Industry 4.0 platform on trustworthiness. I mentioned quite often the SMEs, which are in our focus. Here I would share a screenshot that we did, that I attended a working group together with the METI and a representative from other German federal states. Here listening to a lecture from so-called Mittelstand, or small and medium-sized 4.0 competence center organization in Germany that has been set up across Germany, providing assistance and contact points to German SMEs who are interested in making use of Industry 4.0 applications. So this is a hand-on approach. Those competence centers actually provide the tools, the actually demonstration centers. So they have factory lines that are connected, that are, let's say, smart. They have the experts that consult with the companies, with the engineers or the management. They can, of course, make use from existing best practice cases, so they learn from each other and put this into a larger network. This support is for free for the German SMEs. And you see that we have this discussion with the Japanese METI, gives hope that a similar offer is also being made here to Japanese SMEs, assistance, let's say from top to bottom layer, from politicians, from economic ministries, to help their SMEs in their respective country. Again, it was a very helpful tool from the very beginning that the companies wanted to know specific proven use cases that are, what are the other companies are doing? Peer-to-peer experience is probably the most important ones to see what are the other companies actually put in place, how have they achieved connected smart workshops. So if you go onto this website, the platform-i40.de website in German and English, you will find these maps, these online maps of either Germany, France, or Japan. So these countries put in data, or the companies actually put in the data on a voluntary basis. As of today, I think we have at the moment 384 practical use cases of Industry 4.0 being implemented in German companies. Pictured here as a German map, you can screen, you can hover over the map like a Google Maps map and search for, let's say, an industry or for an application that you are interested in, and see how our German competitors or German partners are coping with this situation. How do they actually realize it? Same as for France, but unfortunately, as you can see, you have to speak French a little bit to understand the French Industrie4.0 projects. But on the right side, you see a quite familiar map of Japan, where the Robot Revolution Initiative, so the strategic partner of the German Industry 4.0, has put up 150 Japanese use cases. For the moment, I zoomed into the Japanese map yesterday and found these use cases are not surprisingly focused and centered around the Kanto Kansai, and of course the Nagoya area, Chugo area, a little bit in Kyushu and Tohoku. But you can see from the screenshot that even Saitama is part of this reference points, and I've done an even further zoom here into the east of west of Tokyo, Saitama, where these use cases come up, and zoomed even further into one company that is in the Saitama prefecture, describing their Industry 4.0 implementation. That's a manufacturer for food. I think it's convenience foods, bento boxes for convenience stores, how they upgraded their automation system in their process line, what their goal is for the future in further automation, and of course using smart data that they generated in the first step. So this should all encourage you to actually also, either if you have already use cases, make those use cases public, or get ideas on how to implement applications. This slide is more an invitation. Of course, together with our partners from Saitama, we were quite successful actually to guide and assist SMEs from Saitama in taking a step towards Europe, towards Germany, towards the heart of Industry 4.0. The heart beats especially strong in the south, in Bavaria and our neighbor Baden-Württemberg, where there's quite a high number of the so-called hidden champion companies, German manufacturing companies that are world market leaders, with a rather smaller size in neighborhood to global players. You find familiar logos here from the automotive machinery sector. So this, I think, is another way of gaining competitiveness. Go where the music plays, if you can say, go where the Champions League is, go right into the southern part of Germany. And to help you along this way, and this is, I think, my concluding slide, we are here in Tokyo in this office building that is here encircled, one of the many Mori towers in Tokyo. This is my team. Tayama is sitting next door, so to speak, listening in. She's, of course, helping many companies, consulting companies, and assisting the companies from the very first idea stage. What can we do in Europe? Is Germany the right market for us? Where can we find partners? How have other Japanese done it? I think this peer-to-peer experience is important. As Invest in Bavaria with our colleagues in Munich, we regularly invite Japanese SMEs to share the experience, to come together from various industries, together with organizations like JETRO, like the Japanese Consulate General, the Japan Club in Munich, or business associations in Bavaria, Chamber of Commerce, for example, to share experience, to really understand what Industry 4.0 can benefit your individual case, that you don't feel lost, you don't feel alone, but you feel more encouraged, and be in good company. So I think that's the main mission also for today's webinar and the upcoming webinars, that you have partners on both sides, make use of the Saitama city colleagues and the Bavarian expertise here from Tokyo and from Munich. We are here to help you, and with that, I would like to hand back to Saitama. Thank you very much for your kind attention.
Well, thank you very much, Mr. Dr. Geltinger. It was a great presentation. So we are going to switch to the Q&A session. We have some question, I guess. I pass it to Mr. Yamamoto. Is it okay for you?
Okay.
Yeah.
Thank you, Geltinger-san. We received certain questions, and the first one has been answered. The company who is interested in doing online matching, and we answered to him saying he's welcome. Second question is asking for the presentation, and we answered to the question saying that the link to the video is going to be published or sent to via email later, so people can see the actual your presentation. And we have other possible questions. I just pick one. To comply with the Industry 4.0, a certain cost can be incurred. And do you think that is an idea for either Japanese or German government to provide a certain subsidiaries as an incentive for companies? Do you think that is what do you think about that idea?
Yeah, let me switch back on the video as well. Yeah, this is very important to not only talk about and encourage and say, let's encourage companies to participate, but also give them an incentive, a financial incentive, because it requires some sort of investment, as I've outlined. And the investment can be a little bit reduced, as I briefly touched upon, by outsourcing some of the setups that you probably have to make in your workshop to these test labs. In Germany, they call test labs. They can be at the Fraunhofer Institute or some other organization where you can actually go and let them do the investment on your behalf. They are sponsored by the government, so this reduces the cost as well. I am hopeful that in Japan, there will be at some point similar partner organizations that do this kind of outsourced, let's say, assistance to test and try Industry 4.0 applications that are suitable for your own case, not for general case, but for your own challenge that you have, your own product, your own requirement from your OEM, for example. And of course, in Germany, we have programs that can directly subsidize companies individually, or if they do joint, let's say, research or investments with other companies. So I assume in Japan, there are similar programs like by NATO or ICE or funding organizations that pick up on, let's say, smart factory investments. But I think the experience sharing is at the very beginning to avoid unnecessary costs. Because as I said, or I think the video also probably made it clear, Industry 4.0 is nothing that you can buy on the shelf. It's not something you can order, and it has a certain price. It is a concept, and you can implement the concept, let's say, in a step-by-step fashion with overseeable investments, or you can just virtually implement an Industry 4.0 application without any physical changes in your factory, and still get results and see if it creates benefits. And if it creates benefits, then I think the investment is worthwhile to take.
Okay, thank you. Thank you very much for your answer. I think the time, Kato-san, in a time-wise, we have to conclude.
Okay, so Okay, I hope you enjoyed our webinar. If you have any other question on this webinar, please send us an email to this address. We will get back to you later. So, 切り替えてもらっていいですか? すいません. Yeah. And then our next webinar will be webinar 2, 5 p.m. Japan Standard Time, 9 a.m. Central European Time on 10th December 2020. Innovative business model for Industry 4.0 in German, Mittelstand, and impact of the COVID-19 crisis by Professor Dr. Michael Dowling, Chair, Innovation and Technology Management, Faculty of Business, Economic, Information System, and Real Estate, University of Regensburg. And then the third one will be 5 p.m. Japan Standard Time and 9 a.m. Central European Time, same as this webinar, on 17th December 2020, strategy of mitigating cyber risks, the approach of Security Network Munich by Mr. Peter Muring, General Manager, Security Network Munich, Alliance Manager, Guy Zecke and Debrien. And webinar 4 will to be announced later. Well, thank you again for your time. So this is the end of the webinar. So if you have any question, you can chat right now, or you can put Q&A still, or you can email me. So
yeah.
Thank you for your time.
Thank you very much also from my side to everyone listening in today. Thank you.
Dr. Geltinger, thank you very much. Thank you very much.
Yeah, you're welcome. I hope it was informative and also understandable, because I think right now there's quite a dynamic situation because of, I think, the COVID crisis. I think that's why the next lecture is probably even more important, to see how the German companies have changed the business model.
Yes. So we are looking forward to also in the next lecture. Yeah. Thank you very much.